This is Pluto, the planet they took away from us. For generations, it sat proudly at the edge of our textbooks, mysterious, lonely, the ninth world circling far beyond the warmth of the sun. And then, in 2006, they erased it. A single vote declared that Pluto was no longer a planet, and we were all supposed to move on. But while the world argued about a label, NASA quietly flew a spacecraft 3 billion miles to find the truth. What New Horizons discovered out there was far stranger, more active, and more beautiful than anyone expected. So, what exactly did NASA find when humanity finally reached Pluto? For most of human history, the solar system seemed simple. But in the 1800s, as telescopes improved, astronomers kept discovering new objects. Ceres, Vesta, Pallas, Juno, each one briefly celebrated as a new planet. At one point, science textbooks listed over 20 planets in our solar system. Boundaries were blurry, definitions were inconsistent, and excitement was everywhere. Then came 1930. A young farm boy turned self-taught astronomer, Clyde Tombaugh, was hired to search for a hypothetical world, Planet X. Something, people thought, was tugging on the orbits of Uranus and Neptune, a hidden giant lurking in the dark. After nearly a year of painstaking photographic comparisons, Tombaugh spotted a tiny point of light, slowly crawling across the sky. He had found it, a new world, and by every definition we had at the time, it was a planet. Pluto was unique. It orbited the sun. It appeared alone in the distant darkness, and it was bright, much brighter than any neighboring object we could see. From Earth, Pluto seemed like the only resident of the solar system's icy frontier, but telescopes got better, and the deeper we looked, the more we found. It wasn't empty out there, it was crowded. Pluto was just the first piece of a vast, icy ring of debris now known as the Kuiper Belt, home to objects like Eris, Haumea, Makemake, and thousands more. Pluto was no longer unique, it was part of a family. Then came 2006, the year that broke hearts. The International Astronomical Union drew a new line in the cosmic sand. To be a planet, a world must orbit the sun, be round under its own gravity, and clear its orbit of similar objects. Pluto met the first two, but the Kuiper Belt was crowded, and Pluto was just one among many. And so, after 76 years, Pluto was officially reclassified as a dwarf planet. But here's the part almost no one talks about. They demoted Pluto in 2006, but in the exact same year, NASA launched a spacecraft to go see it anyway. That spacecraft was called New Horizons, and it was about to rewrite everything we thought we knew. Before we ever sent a spacecraft to Pluto, this blur was the best humanity could do. You see, Pluto isn't hard to see because it's far away. Plenty of things are far away. Hubble can photograph galaxies millions of light years from Earth in stunning detail. But Pluto? The tiny world sitting only a few billion miles beyond Neptune, it shows up as a fuzzy smear. Why? Because of something called angular diameter, how big an object appears in the sky. The Andromeda Galaxy, despite being 2.5 million light-years away, spans about 3 degrees across the sky, 6 times the apparent size of the Moon. Its sheer size makes it easy for Hubble to photograph. Pluto, on the other hand, is tiny. At its closest, it measures just 0.11 arc-seconds across. That's so small that Hubble can barely resolve a single feature on its surface. It's the equivalent of trying to photograph a flower on a hill, while buildings miles behind it appear sharper. We could measure Pluto's brightness. We could estimate its color. We could tell it had a companion moon, Charon. But details, mountains, atmosphere, geology, everything we knew about Pluto before 2015 could fit on a postcard. And that's why we needed New Horizons. To reach Pluto before the mid-2030-50s, NASA had to build something radical. Something small, something light, something fast enough to cross 3 billion miles before its instruments aged out. The result was New Horizons, a spacecraft weighing just about 1,000 pounds, barely heavier than a touring motorcycle. But to hurl it toward Pluto, NASA needed power, a lot of power. On January 19, 2006, engineers strapped New Horizons onto an Atlas V551, a rocket with 5 solid boosters that together generated roughly 2 million pounds of thrust. When those engines ignited, New Horizons became the fastest spacecraft ever launched. How fast? it reached the moon in just 9 hours. For comparison, Apollo astronauts took 3 days. New Horizons didn't stop. It couldn't. It was a flyby mission. No braking, no orbit insertion, just one chance. 1 year after launch, it reached Jupiter. NASA used the giant planet as a gravitational slingshot to boost New Horizons' speed even further. During its brief encounter, New Horizons tested its cameras, snapping detailed shots of Jupiter's storms and even catching a volcano erupting on Io. But the real purpose was clear: increase velocity and head for Pluto. Then began the long silence, the long wait. 8 years of quiet engines and distant telemetry as New Horizons crossed the empty black between Jupiter and Pluto. No sunlight, no planets, just the slow pulse of a spacecraft pushing toward the unknown. For nearly a decade, it sailed through darkness toward a world we had never truly seen. As New Horizons crept closer to its target, Pluto began as nothing more than a pixel, then 2 pixels, 2 faint dots, inching brighter day by day. Those dots were Pluto and Charon, partners locked in a gravitational dance unlike anything else in the solar system. Charon is remarkable. At roughly half the size of Pluto, it isn't just a moon, it's a companion world, and the two are incredibly close, only 19,600 kilometers apart. For comparison, our moon orbits at nearly 400,000 kilometers away. That closeness leads to something rare, something almost intimate. They are tidally locked to each other. Not just in the usual way, like Earth's moon always showing one face to us, but in both directions. One side of Pluto always faces Charon, and one side of Charon always faces Pluto. A permanent cosmic stare. If you were standing on the far side of Pluto, you'd never see its largest moon, ever. If you stood on the near side, Charon would hang in the same spot of the sky permanently, frozen in place like a celestial monument. But the strangeness goes deeper. Most moons circle around their planets, but Pluto and Charon orbit around a point in empty space. That point is called the barycenter, the true center of mass between the two worlds. And because Charon is so large relative to Pluto, that barycenter lies outside Pluto's surface. So, instead of Pluto being the center, both objects swing around an invisible balance point, like two dancers pulling against each other's weight. Only one major system in the solar system behaves like this: Jupiter and the Sun. Their barycenter also lies just outside the Sun due to Jupiter's immense mass. And no, it isn't a black hole. It isn't dark matter. It's just gravity and math. The universe doing what it always does. Pluto and Charon aren't a planet and a moon. They're a binary world spinning together in a silent ballet at the edge of the Sun's kingdom. And New Horizons was now close enough to watch the dance in breathtaking detail. Then, for the first time in human history, this is what Pluto actually looked like. Not a blurry pixel, not an artist's guess, but a world, alive with color, texture, scars, and stories. Pluto wasn't just white ice. It was a canvas of deep reds, burnt oranges, pale blues, and brilliant whites. A world with character. Those reds came from Tholins, complex organic molecules created when sunlight and cosmic radiation hit methane in Pluto's thin upper atmosphere. They fall as a dusty snow, staining entire regions of the surface. The white and yellow tones came from nitrogen and methane ice, gleaming under faint sunlight. The blue haze drifting above the surface, that was Pluto's atmosphere, thin, layered, and far more complex than anyone expected. This wasn't a dead, frozen marble. This wasn't the static ice ball scientists once described in textbooks. This was a world with weather, with chemistry, with geology, with history. A world carved by glaciers, dusted by alien snow, and shaped by forces we were only beginning to understand. The truth hit immediately. We had underestimated Pluto. Everyone had. When New Horizons finally drew close enough to resolve Pluto's surface, one feature dominated everything: a brilliant, pale heart stitched across the face of a distant world. This region is called Tombor Regio, named after Clyde Tombaugh, the man who discovered Pluto in 1930. It is a tribute carved in nitrogen ice, but the most extraordinary part is on the left side of that heart, a vast, smooth basin called Sputnik Planitia. Sputnik Planitia is enormous, a frozen sheet of nitrogen ice roughly the size of Texas, stretching over 1,000 kilometers from end to end. And what shocked scientists most wasn't its size, but its youth. There are no visible impact craters anywhere across this entire expanse. None. In a solar system that has spent billions of years throwing rocks at everything, a surface without craters means only one thing. This landscape is being refreshed, constantly. Sputnik Planitia is geologically active. Around the edges of the basin, towering mountains of water ice rise like frozen cliffs. Glaciers flow from these highlands into the smooth plains, slowly creeping across the surface in patterns that resemble the icy flows of Earth's Antarctica. But make no mistake, the ice here is not like the ice we know. At Pluto's temperature, around -229 degrees Celsius, water ice is so hard it behaves like solid rock. It forms mountains, cliffs, and ridges. The soft stuff, the material that flows like glaciers, is nitrogen ice and carbon monoxide ice, which remain far more pliable in Pluto's deep freeze. And then New Horizons zoomed closer and revealed something even stranger. Across Sputnik Planitia are enormous polygonal convection cells, giant patches of terrain, 20 to 40 kilometers wide, outlined by dark troughs. They resemble a frozen quilt stitched by unseen hands. These polygons are created by heat rising from Pluto's interior. Warm nitrogen ice deep below slowly rises upward, spreads out, cools, and then sinks again along the edges, a planetary conveyor belt that has been running for millions of years. This meant Pluto has an internal heat source, something warm enough to churn ice on a world once thought completely dead. And here's where it gets even more astonishing. As the upper layers of nitrogen ice warm, they don't melt, because on Pluto, nothing stays liquid. Instead, they undergo sublimation, turning directly from solid to gas. That gas rises, forming a thin but stunningly layered atmosphere. New Horizons photographed dozens of delicate haze layers, sheets of blue mist stacked one atop another like cosmic veils. When the spacecraft flew by, Pluto's surface pressure was about 1/1,000,000th that of Earth. Barely anything, a whisper of an atmosphere, but Pluto's orbit is wildly elliptical. During the part of its 248-year journey when it moves closer to the Sun, sublimation increases dramatically, and the atmospheric pressure could swell to as much as 1/4 of Earth's, even exceeding the surface pressure of Mars. Under those rare conditions, liquid nitrogen may briefly pool on Pluto's surface. Yes, Pluto might have once had lakes of liquid nitrogen. This little frozen world is alive. Beneath the heart of Pluto, something ancient is still moving, still breathing heat into the darkness. If Sputnik Planitia is Pluto's heart, then this is its scar. A massive, sprawling, dark red region snakes across Pluto's equator, stretching thousands of kilometers. Its official name is Cthulhu Macula, though scientists also call it Belt Regio. At first glance, it looks like dried blood smeared across an icy world, but the origin of this color is far more fascinating and far more alien. It comes from Tholins, complex organic molecules created when ultraviolet light and cosmic radiation strike methane and carbon dioxide in Pluto's thin atmosphere. Over time, these molecules bond into larger structures, turning a deep red. Then they fall gently onto the surface like chemical snow, accumulating over millions of years. The distribution of this red dust is not random. It follows the flow of Pluto's icy winds, the sublimation cycles of nitrogen ice, and the gentle currents of the atmosphere. In some places, the Tholins are swept away into plains and basins. In others, they accumulate into dark, ancient deposits. This red stain is more than a geological feature. It is Pluto's memory, a record of how sunlight, chemistry, and atmosphere have sculpted this world for eons. Pluto's heart wasn't the only shock New Horizons delivered. As the spacecraft swept past the planet, its cameras captured a colossal mound rising out of the icy crust. A structure so huge, scientists needed time to believe what they were seeing. This is Wright Mons, a 5-kilometer tall, 150-kilometer wide dome of frozen material. Not a mountain, not a crater, a volcano. But unlike Earth's volcanoes, Wright Mons doesn't erupt lava. It erupts a slushy mixture of water and methane, a cryovolcanic brew that oozes and freezes in Pluto's eternal cold. And here's the part that stunned geologists. Across the entire structure, this enormous, sprawling formation, New Horizons found only one visible impact crater. Just one. In planetary science, that's a blinking neon sign that shouts, "This is young, recent, active." Based on the freshness of the terrain, Wright Mons might still be erupting. Not in human timescales, but in geological cycles. Maybe once every few million years, Pluto's interior pushes up another pulse of icy slush, refreshing the landscape. Cryovolcanism is something we've come to expect from the icy moons of giant planets, worlds squeezed and heated by powerful gravitational tides. But Pluto? Pluto is alone. No massive host planet, no tidal needing, no obvious source of internal energy, yet here stands Wright Mons, proof that something inside Pluto is still warm, still active, still capable of reshaping the surface. But where is this heat coming from in such a tiny world? The existence of Wright Mons and the convection patterns beneath Sputnik Planitia pointed to one unavoidable conclusion: Pluto isn't cold all the way through. Deep beneath its frozen shell, scientists believe there is warmth. Enough warmth to keep parts of Pluto's interior mobile and possibly even liquid. The evidence suggests that beneath the crust lies a subsurface ocean, a global or semi-global layer of liquid water mixed with antifreeze compounds like ammonia, just like Europa, just like Enceladus, just like Titan. But here's the mystery. Those moons stay warm because they orbit giant planets whose gravity stretches and flexes them, releasing heat in the process. Pluto has no such parent. No tidal heating, no gravitational furnace. So why hasn't Pluto's core frozen solid after 4.5 billion years? One leading theory points back to Pluto's origin. Billions of years ago, Pluto and Charon may have experienced a massive collision, a violent impact that melted large portions of both bodies, causing them to reform as a binary world. That collision would have injected enormous heat into Pluto's interior, and over time, as Pluto cooled, its thick outer shell of rigid water ice may have acted like a thermos, trapping heat deep inside, slowing the freeze, and allowing a subsurface ocean to persist to this day. This ocean might be hundreds of kilometers beneath the surface, it might be global, and it might still be interacting with the crust above, powering convection, driving cryovolcanism, and shaping terrains like Sputnik Planitia. When you look at New Horizons images, Pluto appears bright, glowing as though it's bathed in generous sunlight. But remember, Pluto orbits up to 4.8 billion miles from the Sun. Sunlight there is only 1/900th as strong as it is on Earth. So why does Pluto look so well lit? To understand this, scientists use something called Pluto time. It's the amount of sunlight Pluto receives, equal to the level of brightness on Earth during deep dusk, just after the sun sets, but before night fully takes over. That's the real lighting New Horizons was working with. The spacecraft compensated using long exposure times, careful orientation, and image processing. Nothing artificial, nothing unrealistic, just clever engineering letting us see a dim world as it truly is. But there's another reason Pluto looks bright. Its surface is extremely reflective. Nitrogen ice, methane ice, and carbon monoxide frost all have high albedo, meaning they bounce sunlight back efficiently, like powdered snow sparkling in twilight. Even under the faint glow of a distant sun, Pluto shines. So yes, Pluto is dark, but it also glitters, a world of ice mirroring the sky, illuminated by the thinnest trace of daylight. In July 2015, after traveling nearly 3 billion miles and spending only a few days in close approach, New Horizons completed humanity's first encounter with Pluto. And just like that, the moment was over. But the spacecraft didn't stop. It couldn't. It was moving too fast. New Horizons plunged deeper into the Kuiper Belt, aiming for its next target, a contact binary object called Arrokoth, formerly MU-69. On New Year's Day 2019, it flew past this strange, snowman-shaped relic of the early solar system, capturing the most distant flyby ever performed. And even now, years later, New Horizons is still awake, still listening, still sending back data. It measures dust, plasma, solar wind, and the faint whispers of the Kuiper Belt, a region we have barely begun to understand. But there's a bittersweet truth. There is no planned mission to return to Pluto anytime soon. The distance, the cost, the complexity, all enormous, which means these may be the last close-up images of Pluto in our lifetimes.